as my win for the if you have to come back to this, to work at things at your own pace, or if your robot isn't charged and you don't get it charged enough in our time, feel free to come back for this recording. So with that being said, I'm going to switch devices here so that we can see my computer, and we'll get started. So Bolt Plus is a brand new version of our spherical robot. So has anyone on here, and feel free to unmute and say it or throw something in the chat or react. Has anyone used Bolt or Spark Plus or any of our previous round robots? Just Alexis? Okay. All right. So it is a totally new robot under the hood. We have reinvented the round robot with this iteration. So on the surface, it looks like there's just a few changes, but it's actually a whole new robot. So with that being said, there's this fun little video that you can find on YouTube. It's called It's Alive. For the sake of time, I'm going to jump past this one tonight, but it's really fun. This is one of my coworkers, Nate. He is the product manager on the Bolt Plus product line. And he did some really fun recording here. So check it out on YouTube. You can just search Sphero, It's Alive, and you'll find that one. But really, really pretty fun. All right, so all about Bolt Plus here. You can program it three ways. We're going to focus on just one of those in our sessions here. But we have draw-based programming, which is where you draw a path and the robot will follow that path. We have block-based programming, which is where a majority of our users live in that. And we can also program with text-based coding. Right now, that's JavaScript, but I'll give you a quick sneak peek on some things that are coming. We have JavaScript coming to, or beyond JavaScript, we have Python coming to our app for our programmable robots. And that is coming very soon. So hang tight. It'll happen in 2025 somewhere to bring Python to the mix. Bolt Plus itself has a bunch of sensors in it. Infrared sensor, which allows them to communicate with each other. The cool part is Bolt Plus, and RVR Plus all have those same infrared sensors. So you can communicate between all three of those robots on up to 8 different channels. So you can send messages to initiate segments of code and all kinds of really cool things like that. They can follow each other or evade each other, which is a really fun thing to do if you can kind of recreate the game Pac-Man. Is a cool exercise in programming. So doing those kinds of things. We have an ambient light sensor that reads the light level in the room. So you can code based on how bright it is in the room, which is really, really fun. And then we have this 6-axis IMU that's in there. Basically, it's a sensor that tells where this thing is in space, how it's moving, how it's accelerating. And we can see all of this data from all of these sensors on the programming device. But since Bolt Plus now has an LCD screen, we can actually show all that data on the screen as well, which is really, really awesome that we can do that on both on the robot and on the programming device. Something new that we've added to this iteration of the robot is the ability to drive while inside of a program. And what I mean by drive is manually drive inside of the program. Some students find with these robots that, hey, once they figure out that they can drive it around, they don't want to program it anymore because it's just too much fun to drive it around. So we're providing some tools to be able to enable students to enjoy those manual driving kind of features while inside of a program. So you can turn driving on, turn driving back off. There's some really cool lessons that go with that particular feature that's in Sphero EDU. And we'll talk about Sphero EDU here in just a moment. One of the questions that we used to get asked about all of our round robots before is, If I want to move a certain distance, what does my time and speed need to be? And I always answered that in a very simple way of yes, you need to set time and speed, but it is all dependent on what kind of surface the robot's rolling on. We have changed that and added a new programming block that works with Bolt Plus as well as RVR Plus, where it allows you to roll to a specified distance. So now you can say, I want to move 50 centimeters, and the robot's going to roll 50 centimeters and stop. So you can set that distance. It's using those sensors in order to be able to calculate how far it actually moves. The most obvious change is that LCD screen that we've added there. We used to have an LED matrix on there. So now we can display all kinds of images, animations, sensor data. All of that can now show up on that awesome little screen that's there. Don't worry if you are familiar with Bolt at all and had the LED matrix and enjoyed how that worked and being able to program your own things on there. You can still use those things and they're actually emulated on the screen. It looks super cool to see all those like little LED-esque dots on the screen. It's really, really pretty fun. So you didn't lose any capability with this new robot. And we did add something called software button events. So button events, it adds up to 3 software buttons into your program, and then you build off of those events with some blocks. So when you start your program, you can have up to 3 buttons appear, and clicking on those buttons will enable whatever code you've programmed to execute, which is adding that fun interaction that all the students are looking for with the robot. So this is what the robot looks like with the fun exploded view of it, what we can see on the inside. This also shows up in our app, by the way. So you can see what it looks like on the inside. Don't worry, none of them were harmed in the making of it. Beauty of CAD. So I mentioned draw programming. This is like your first intro to coding on this kind of a device. So if you're using Indy and then you're moving from Indy to Bolt, or in this case, Bolt Plus, this is a great way to do it. You want to do 1 or 2 kinds of activities here and then move on. You don't want to live in draw programming forever. It's just kind of the intro part of it for students. It's a great segue into the coding app and doing things like that. So really easy, set a speed, set a color, draw a path, and off the robot goes to follow that path. So very simple to get them using the robot in a fun way right from the beginning. Then we move on to blocks. So these are drag and drop, snap the blocks in place, very easy programming, but it allows a lot of room to grow. So you can start very simple, like we will tonight, and you can get into some really complex programs with block coding. So it doesn't have to be super simple. And then, of course, we have our text base, which right now is JavaScript. It's a text syntax. So learning that text style of programming. We do have our programming wiki, which is all about the different commands that you can give it. The other cool part is since under the hood, the robot really only understands JavaScript, we can convert our block program to JavaScript so we can see it, which is really great when our students are transitioning from block to JavaScript so that they can see what that looks like. And that will also be the same when we introduce Python as well. So really pretty cool that we can kind of fluidly jump between those different types of programming. All right, so let's get started. Let's get hands-on with this thing. So if you didn't download the Sphero EDU app, don't panic. I'm actually going to show you one of our new tools. If you did download the app, great, that's awesome. You can use the app. I'm going to demo tonight from our iOS version of the app. I'm going to use an iPad to do it, but you could 100% do this from a web browser on a computer as well. So we do support pretty much every platform. It's iOS, Android, which includes your Chromebooks. We also have Windows, Mac, Fire OS, and now our web app. So I'm gonna jump to my web browser here for just a moment. And I'm going to go to Sphero Central, which is edu.sphero.com. And I'm going to throw that in the chat just in case anyone needs it. But when you jump into here, this is kind of your one-stop shop for all kinds of Sphero content. So I'm going to click on Bolt Plus, Rover Plus, Mini. Also note, if you have any of our older programmable robots, this is the same place that you will go. The list is pretty long. It would have taken up half the page. So we want to make sure that everyone can find that kind of content. When you go there, if you scroll down where it says getting started, you can download the app or you can choose Open Web App. So if you haven't downloaded the app, the quickest way in, click on Open Web App. And when you click on that Open Web App, it's going to open up for us here. I believe I'm already logged in. I'm going to sign out so that you can see the same thing or you're seeing the same thing I'm seeing. And this is what it'll look like. And we can connect to our robot up here by clicking connect. We're going to choose Bolt Plus. It's going to ask us to pair that. And I'm going to pick up the robot, give it a shake. You'll see the display will turn on here. Oop, let me get to the right camera. There we go. So we can see the display is going to turn on. It's going to cycle through its connection ID and a bunch of other things. I'm going to click on the connect button on my window, choose my robot, which, by the way, if you're familiar with Bolt, it's really nice that the connection ID is printed right on the robot. I'm going to hit pair. It's going to connect to the robot. I'm now connected. Up top here, we can see the charge state of my robot, the name of it. And if you're unsure of where that's listed, it's not only will it cycle through the screen when it's powered on and not connected to, but it also shows up on the license plate down here. And that license plate has that nice blue background with the darker text there. If you're familiar with Bolt and have experienced that with Bolt, what happened with Bolt is it was like gray on gray underneath the robot. It was really hard to see. So we wanted to make this as easy as possible for you. Once you're connected, we can start to program. So I'm going to actually disconnect my robot and switch over on devices to make my life a little bit easier here with this. So if you're doing this from, say, an iPad or right from our app, up in the top right, we have Connect. I'm going to choose Sphero Bolt Plus. Here's my robot. If it falls back asleep, you can shake it and connect. That same process. Do note that once you're connected, you can go here and you can do Find My Robot. You can also disconnect from here. Note that when you exit the app, it automatically disconnects. And if there were to be a firmware update, which there was recently a firmware update released, this is where you'll find that firmware update. Our firmware updates on Bolt Plus are optional, so we don't force you to do them. I would say don't do it right now just for sake of time. It takes about 2 to 3 minutes to do a firmware update on the robot, so it's not killer on the time factor, but we do want to keep moving here tonight. So with that being said, once we are connected and ready to go, a couple best practices here are a 2-to-1 ratio. We usually say 2 students to 1 robot is best with them. And we have 2 different kinds of aiming. So if you're familiar with Bolt, you used to have to, when you aimed Bolt, you would have to go to the aim menu and turn it. And when you turn that dial, you'll see that the robot actually moves as well. But that isn't necessary now. We can take the robot and physically turn it to what we want 0 degrees to be. So 0 degrees meaning straight forward, what we want. So I can just physically rotate it to do that. So 2 different ways to aim it. And now we're ready to program. So just some of the things to note here in block coding. All of our categories along the bottom are color coded. So students always want to program things in the most obscure way possible. That is what students do, right? It is just kind of human nature for students, right? So when we look at their code, there's always a question of like, what is that block? Where did you find it? And what is it doing? Well, I can help answer part of that right away. Where did they find it? Look at the color of the block. So here in this example, we have a movement block, and we can find that color down here at the bottom. And once we find that color, that's the category that it lives in. We also have found that we have a lot of blocks in our block programming environment. We don't want to make it super crazy difficult to find all of our stuff. So what we've done um, is simplified the categories. So we take the most commonly used blocks. They're the ones that automatically display, but we didn't get rid of anything. They're all still there. So if you're looking for, is there more I can do in this category? When you're inside the category, click on the little arrows. It will expand it to more blocks that are available for you. So that's super helpful as well. All right, so we're going to start coding. Then I'm going to come back to this challenge card that's here. So from my programming device, I'm going to hit create program. Three things we need to do here is we need to name the program. That is super important. So I'm going to call mine Square. I want to just call mine Square Demo because I know I have one there that's already called Square, but I'm going to do Square Demo. I'm going to choose the type of program. So in this case, block. And since we're already connected to Bolt Plus, that's going to be there. But if we weren't connected to Bolt Plus, we would have to pick the robot that's there. Notice that some of the really old robots are still in here. You can still program your old robots. So I know some people have some of the old fun Star Wars robots and things like that that are hiding up here. And if you have any of those, you can still program them in Sphero EDM. Once you have everything selected, hit the create button. We will now be in the coding canvas. The coding canvas, we always want to make sure blocks are attached to an event. So by default, we have one event, it's on start program, and anything that's connected to that will be triggered when we hit the start button. So this is part of challenge card 1, which comes in the set. And if you only have an individual robot, don't panic. You can download a PDF of all the challenge cards and print them out on Sphero Central under our resources page. So these are all available. So challenge card 1, I'm going to walk you through it. It explores the difference between the traditional roll block and the roll block, the roll to distance block. So roll block, roll to distance block. So what we want to do is we want to take this first roll block and attach it to OnStart program. So there's 3 parameters to any of these roll blocks. We have 0 through 359 degrees. That's the direction it's going to go. 0 being straight ahead, straightforward, based on how we aimed the robot. Do note that if you're like me and you're like trying to get that like 1 degree and you can't get it there, you can tap on the number and actually type the number in. In this case, I just want 0, so I'm going to set it to 0. But you can tap on the number and type it in. Then we have speed, and speed goes from 0 to 255, 255 being the highest. And I know some of you probably were on the call the other week for RVR Plus, maybe. And if you were, I already explained a lot about why the 255, 0 to 255 gives you 256 steps of speed. Has to do with bits and bytes. It's super intriguing. One night when you can't sleep, do a Google search of why is 256, the number 256 significant in the programming world. You'll be asleep in no time. You're welcome. And you can move on from there, right? So what I always tell my students is I worked with high school students, pick a moderate number. They, like all good high school students, would crank it up to 255, see that it goes that high, they drop it to 250, and then wonder why Bolt did like this big burnout on the smooth tile floor before it started to actually move, right? So when I say a moderate number, somewhere in the middle, right? Pick a number there and go with it. If you're on a rough surface, you might have to turn the number up to have enough power to get it moving. If you're on a really smooth surface, turn the number down so that it stays nice and controlled and it doesn't kind of do a burnout, slip around. And you can set that number. Now, I told a little white lie here. I said it goes from 0 to 255, but you can go in reverse as well. And then it is a negative number, right? So it actually goes negative 255 to positive 255. So 256 steps forward, 256 steps backward. Then we can set our time. This is the amount of time that Bolt Plus is going to roll forward at 0 degrees at a speed of 110 in our particular program. So I'm going to set this to 3 seconds for now. If you're dealing with a small space, you can reduce your time or reduce your speed, right? Speed and time work together to make a distance. Then under my controls category, I'm going to go grab a delay. I'm going to add a delay there. I'm going to set it for 1 second. You can set it to whatever you want. Basically what this does is it gives enough time for the robot to come to a complete stop before it executes the roll to distance block. So here, I'm going to set my heading to 180 degrees. So it comes back. I'm going to set it to the same speed that I had earlier. So I'm doing 110. I think the challenge card shows 100. You know, pick a speed. Keep it consistent between the two of them. And then I'm going to set this to 100 centimeters. Remember the conversion here, 25.6, right? So millimeters to an inch, right? So 2.56 centimeters to an inch. So if you're trying to do the math in your head here, it makes it easy for you to do. So now what I'm going to do is I'm going to start my program. So I'm going to make sure I aim to my robot. So I'm going to do that by setting which way it's going to go. My robot's not actually going to travel anywhere because I have it sitting on this pad. So it's just going to spin here. And then back in my app, I'm going to hit the start button. When I hit the start button, it is going to start to roll. Then it's going to turn around and it's going to roll back. So since it's on this pad, it's kind of like bouncing around a little bit. My data is not going to be perfect. But when we look at it here, you can see they didn't go quite the same distance forward and back. So in this challenge card, we would experiment to get them to go equal distances. If you're doing this on the floor, you're probably going to see this much better in your data than I am. So I told it to go, 100 centimeters back, but in reality, this thing traveled a little over 207 centimeters. So that means they're not exact. So chances are that this top roll block, the roll for time, is going a little further than the roll to distance. So I could do one of two things. I could experiment with this speed or time, or I could experiment with my roll to distance block. So my guess is, looking at the math, this was about 107. Should equal my first roll block. So now, before I rerun this, notice that my robot is facing the 180 degrees. If I start my program right now, this direction is going to become 0, and that direction is going to be 180. So it's going to be backwards. So I want to take my robot, spin it around so that I aim it correctly. And I'm going to hit start and try this again. So it's going to start moving. I'm going to switch back to my iPad here. Got about 107, 8-ish. It's coming back about 217. And my math on that should have been right around 214. So I'm looking like I'm really pretty close here. Again, it could be because I'm on this little pad that doesn't allow it to kind of move so smoothly. But we would experiment back and forth with getting this to roll the same distance. So this is challenge card number 1. If you're still experimenting with this, please do. Please play around with it. I want you to be hands-on with the robot while you're working on that. There's a bunch of challenge cards. I think it's a set of 20 challenge cards that come in a power pack. So if you ever purchase the whole case, it's 20 of those cards. They're all different things. This is challenge card 1. It's the very basics of like, let's get this thing moving and learn the difference between those two roadblocks. But there's many, many others that are in there. So here's one that allows you to manually drive. So what happens is when you start this program, it will say ready, set, drive. It's going to turn on manual driving. You can manually drive for 5 seconds. It's going to turn manual driving off. So then the robot's going to stop moving. And then it's going to say, it's going to play that random 8-bit sound from that 8-bit category. So you're like, okay, that's cool. They manually drive it. But how is this like actually part of the educational process, right? Like what can we do educationally this way? So a really cool activity or lesson that we can do with it, it's called Bolt plus Darts, which sounds like a game. And most kids probably think it's a game, but it's actually teaching them spatial reasoning. So what happens is at the beginning, Bolt Plus is going to spin randomly for a random number of degrees, and then it's going to reset its heading. So maybe at first this was 0 degrees, but then Bolt spun a bunch of times, and then it ended up this way is now 0 degrees. But I have to go to a target that's over here. So now students have a certain amount of time to manually drive their robot to that target. But if they drive forward, they're actually going to go further away from the target. And what they actually need to do is drive backwards in this particular case. But since it's random, it's different every single time. So it's really helping students develop those spatial reasoning skills of understanding the degrees and what the control is on the screen versus how it's working in the real world with the robot. So you can do some really cool things that are very fun and engaging for the students, but are working on real skills for them. So that's a fun way to do it. We also have a bunch of images and animations that are on there. So challenge card number 9 is called Metamorphosis. And this is going through the life cycle of a butterfly. So it's using all of the images that are related to, the life cycle of the butterfly. And it's displaying them for a certain number of seconds, right? So they have to really think about, well, how does that life cycle work? All the images that were put on the robot are put there for a reason. It's not just a bunch of random things. There's some kind of content use for it. And there's a lot of things beyond just the life cycle of the butterfly. Reading a clock is a thing, right? So we have all of the hours in a manual or analog clock that students can use those images. You can randomly, access them. There's an animation that cycles the clock. So lots of really cool things. While you're playing around with it, I 100% encourage you to add some style to this. So if I go under the display menu, I can display an image, and I'm going to drop it in at the top here. And when I go into that, there's all kinds of things there. I'm going to go under the emojis, and there's some fun Sphero emojis that are in here. One of the first Bolt Plus trainings I did was at the School District of Philadelphia here in Pennsylvania, and for some reason, all of their teachers wanted a like a stress ball of the angry Sphero emoji. I don't know. Seemed to have been a crowd favorite there. Maybe it's just Philadelphia. I'm not sure, but a lot of none of them were angry this week after the football game. I don't know. So seemed to be pretty happy about that. So if we're looking at the football game, maybe wear sunglasses or some of the smiling emojis, right? So you can pick an image that's in here and apply it, and then after that roll block, I'm gonna add a display animation in there. And again, there's all kinds of categories that are in here. So you can find different things by, digging through the categories. And you can even search. There's a search function in here, right? So I can say drive in there. Whoops, try that again. Drive. And now get all of the drive animations that show up. You can browse through. There's tons of different things here, lots of fun things to do with that. So maybe I'll do my car driving here, and I'm going to put after my delay, I can put in some text, right? And I can do that. And I can add an animation to the end of whatever it is that I want to do. So there's tons of different things in here. Play around with these categories because there's really a lot of fun things here. I'll do the loading loading bar here. So now when I run my program, I'm going to hit start. I got that emoji. It was driving, waiting. Now it's going. And once it stops with its movement, it will give me that loading bar. So you can do some really fun, cool things, really jazz up your programs, whether it's just in movement or anything else. Do note that when you're manually driving the robot outside of a program, you can change all of these things too. So if I go up here to my drive, next one over, try that again. I can go in and I can change all of the different things that are in here if I want. I can change the color of the LEDs, and all of these things are happening live on the robot. So I can change all those fun parameters right on the robot. Whenever you're doing any of these programming kind of activities, adding some style is always a lot of fun. So adding things like light blocks, sound blocks, image blocks, animation blocks is really engaging for the student. But they're powerful tools, and you can use them in really fun and creative ways. One of my favorite things to do with almost any of our Sphero products, especially Indy and Bolt, is storytelling, right? So take a story, retell that story in some way. And it's really fun here because you can use those light blocks, those sound blocks, those images and animations to really take Bolt Plus and turn it into that super engaging character in your story. So really cool to do. When we're looking at those sound blocks, there's two things we need to look at there. There's two different sound blocks. So that random sound and where it's playing a sound, and the speak block. So where it says random, again, tons of categories. You can pick a category, you can throw some things in there. I can take an airplane sound, and all of these sounds play on your programming device. There is no speaker on the robot itself. The robot is waterproof, which allows it to do some really fun lessons in water. But if you put a speaker in there, it would just sound pretty bad. So we'd want to, avoid that, and we play the sounds through the programming device. So you can pick sounds there, and then you have the speak block where you type in whatever you want the programming device to say. And I'll just repeat that one more time so we're all on the same page. Whatever you type into there, the programming device will say. High school students, as you would imagine, will type in some interesting things into there, as well as probably some other age students too. The only way those things don't happen is if your IT staff eliminates them out of the device's dictionary, which is something that can happen in any operating system. So I'm operating on an iPad. My IT staff could very easily load a dictionary that doesn't include all of those words that we don't want our device to say. And by the way, this is true on any text to speech program. So even in Google Docs, this is a possibility that students could misuse it in that way. So anything they would type in there, it would say, right? Whoop. Whole thing about a space bar, right? Try that again. And the next thing I want to show here is at the end of each of those sound blocks, there's a little something that says wait. And if you tap on that, it goes to continue. And this is, think of this as a built-in delay. That's the length of the sound. So say the airplane sound lasts 3 seconds. If I have it set to wait, it's going to start playing that sound, and it's not going to do anything until the sound is done playing. Then it's going to go to the next block. So if I took this and I dropped it in here between my display animation and my display text, I can now get rid of my delay. And the way I did that was I just press and held. I'm going to do delete this block. Now that airplane sound is my delay in here. But if I take this speech block and put it up here and I switch it to continue, what it's going to do is it's going to play the sound. And as soon as it starts playing the sound, it's immediately going to go to the next block. So it's going to appear as if something is happening or two things are happening at the exact same time. So that being said, I'm going to turn this on and re-aim my robot to 0 degrees. And I'm going to hit start. Hopefully we can hear this.
Let's go.
So you can see how you can use those sounds and that wait and continue functionality in very creative ways to, make that program not only fun, but also functional for your students. So lots of really cool things that you can do with them. One of the challenges I like to do is programming a square. So when you're programming a square, this program could look like multiple roll blocks here. I'm gonna use the new fun roll blocks. And I'm going to set this to 0 degrees. And it's not cheating, it's using your resources. If you press and hold on this block, if you're on a touch device, if you're on a computer, you can right click. I'm going to choose duplicate. And I'm going to set this to 90 degrees. And if I do that duplicate again on the top block, it's going to duplicate both for me. Now I can set my third one to 180, my fourth one to 270. I now have a square. And again, jazz it up, make it fun, add in some animations, add in some sounds, add in some displays and LEDs, lots of fun things that you can do here. My robot will now travel in a square. So if I'm looking at my robot, set it 0, hit start, it's going to roll forward. It's going to turn 90 degrees, roll again. Going to turn to 180, roll again. My pad definitely throws off my data pretty good here. And then it will stop. And just to see what this looks like, you'll get better data if you're doing this on the floor than I did. And looking at the data, we can see all that live real-time data coming back to us. All I'm doing is swiping between all of those, including the ambient light sensor. So you can see when I move my hand away, it's pretty bright. When I put my hand over it, I can get it to really drop pretty low. So you can get some really interesting data. And that data is data log. So up in the top right corner, we have the 3 dots. If I hit that, I can hit sensor data. And this allows me to export my sensor data as a CSV file. And I can take that spreadsheet then and open it in Excel or Google Sheets, whatever you might be using, numbers on the Mac, and open that data up and use that data that's in there for the lesson. Egg drop activities, things like that, where you're building around Bolt Plus and you're really using Bolt Plus as a sensor. You can then get that data back from the robot to see what the impact really was like. Not did the egg break or not. It's no longer binary. You can now look at the numbers that are there. So really pretty cool. And then when you want to take that up a level, you can start to make different kinds of shapes. So different polygons, things like that. And then the advanced level is to then, do this with a loop without using roll blocks, using the individual blocks, kind of taking this so much further. I want to show one last thing, and that was on Sphero Central. It was the same way that we got to the web app, but up on the same portion here, when you click on Bolt Plus, Rover Plus Mini, you can click on lessons, and this is where you can search our lesson collections, our individual lessons. There's tons of things here. So if you just got Bolt Plus and you sort by Bolt Plus, I would start with the Bolt Plus Programming 1.0, start with those lessons, and you can kind of move further through these. If you start to find that the lessons are maybe going deeper than what you need programming knowledge, start to jump to different topics. There's some really fun engineering design ones, language arts, science, games. So there's tons and tons of really fun lessons that are in here. And just so you know, Bolt Plus is backwards compatible with everything that Bolt could do. So if you have a favorite Bolt lesson or you find a lesson that's only for Bolt, no fear, you can do it with Bolt Plus as well, the same way. So I know that was a ton of information in a really, pretty short period of time. So hopefully you got to at least connect to your robot, maybe get it moving or play some sounds and do some things like that. Like I said, come back to this recording if you need to experiment some more, but also go to Sphero Central. That's edu.sphero.com. Find some content, experiment with it. And I know a little later next month, we have another Bolt session, which will go over some more advanced concepts.
Thank you so much, Brad. Did you guys have any questions you wanted? We got a little bit of time. Please forgive my barking dog. A little bit of time if you want to throw in the chat or even unmute. We're taking all kinds of questions. As Brad said, we are going to see, I think, most of you again at the end, toward the end of February when we do the Bolt 2 session. No question.
I will just
yeah, there
say
we go.
I did get mine to charge, and I was able to get it to go in a square.
Awesome.
So
Great
I was
job.
able to do that, and I got it to talk too. So
Awesome. That's awesome. Great job.
that's a huge accomplishment for me on a Tuesday evening.
Yeah.
Hey, Tuesday evening in less than an hour. Props to you. That's awesome.
Yeah. So that was great. Thanks so much. I appreciate it. I know I'm going to go back and listen to the recording and take, start and stop it so I can make sure I get everything. But that was really easy to do, and I think that the kids will love it too. So thanks so much.
Well,
Yeah.
but I don't want to lose anyone. I want to make sure that you guys have our survey. Let me go and copy that really quickly. And I'm going to put it in the chat. If you've got questions, please ask. Let's see. Christy, she said. I gotcha. Definitely get a chance to play. And hopefully what we're looking at, one, when we have our next session with Bolt, we're going to look at some more advanced things, but also once you guys have had a chance to play, once we've come back together, we may hopefully have the opportunity to come back together where you guys can share some of the things that you've done using your devices. So that would be really nice. Thank you, Christy. I appreciate you coming and hanging out with us. Thanks for joining us, Emily. All right, well, if you guys don't have questions for us, as my director, Joanna, says, I'm going to give you back 5 minutes of your life. If you have questions and you want to hang out, just stay and we can get them answered. But thank you guys so much. We're going to get this posted on to, hopefully, as long as I know how, we're going to get this posted on to our TSEP YouTube account so that it'll be available for viewing. Bye, guys.
Thank you all.
There we go. All right, let me stop recording.